想累死人是吗？我到现在还落了一个什么，刚刚把全部都四个打了。
OK，
嗯，
要不要叫他们帮你打？打吧，好吗？
他们都没空，
做作业
你也不看看你自己，不知道下面有多难。
啊？OK，对，
基本上我分布他们干点都会来推去的，然后到最后还是得我自己干。所以基本上我就只要他们画画题
做题啊。
基本最重要的部分基本上现在我自己一直在干。
啊，对，看一下，
也还好，现在只是24、我要27、28、29、56个是吗？快结束，
呀，快结束
你今天不会又要30
啊？
你今天不会又要30多页吧？
不知道哎。这样子去。来，差不要干嘛？结账，结账。
然後他俾個嚟標榜咧搞嘢嘅，然後他還玩太狗，因為什麼事情，然後就跟我講，然後我就把那個賣完給他，現在沒有發現到很多。他是中國人呢，他應該是很招真好吃，叫什麼？他要俾上情色那個很兩個，他這是日本這樣。
你平时不是做这边吗？
哦，
你平时不做？
我没有记，他今年记忆有点穿来跑去啊。
大概是那个区域。啊？什么？
他能在后底那个抽上来。
有吗？有抽啊？抽。
有没？
没水罢了还是什么？
抽啊！你可以吗？我看这样态度。
他都
我全部写了，全部写了。谁抽了？谁抽了？
跟有人抽了，他们抽什么东西？他们抽什么东西？
你们早走。哎，今天我9点前要回来，9点半、8点半、8点。
吃妈妈。我等下去洗妈妈。
Okay, testing. Okay, let's start. So before we start, have anyone seen this flyer before? Huh? You don't come to this SMUM because of this flyer. Yeah. Yes. Only 1,000 users. I think China students not really know because this one is for recruitment for this university. But China student come here through Chinese higher. Hey, why you got it? 说你有，说你没有，拿给我看，给我看。对啊，中国学生应该是高考来的，但是大学在马来西亚是私人大学 ，so they need to do promotion. 都是你的 flyer for our program. But we're going to update this program again because the information here is not very clear and not very attractive and not updated. So I am doing the updating work for this flyer here. I have a draft. Okay, so maybe you will have a privilege to look at it first. And then I want you to give me some suggestion. Okay, from your point of view or from your parents' point of view. Okay, when they read this thing, what they want, what they expect. Okay, huh? 啊，我要改，我会给你们看那个 draft，然后你们可以给一点意见。Okay, so you can give opinion based on your own study experience here, or you can give opinion based on your parent. Okay, parent view. OK 吗？看一下，如果你是你的孩子，不是，你是你的孩子的家长，啊，看到这个，你会让他进来读吗？OK。Okay. Okay, so before we start, let's do some revision. Yeah, let's do some revision. Okay, let's pick up from what the example we left last time. Okay, so let's look at this ring homomorphism here. What's this ring homomorphism here? So you basically pick a polynomial over z, and then you evaluate x at 0. After that, you are left with a bunch of numbers, and then you add them together, you compute it in mod p. Okay, so for example, let's say we take x squared plus 2. So if x squared plus 2, you map it across, what do you get? You get 2 mod p. Okay, yeah. So you're left with a number, correct or not? Fp is a number, right? How many elements in Fp? P, right? Okay, so you have 0, 1, 2, up to P minus 1. Okay, so the question is, what's the kernel of Phi? What's the kernel? What are the elements get evaluated to 0? P, right? For example, P get evaluated to 0. And then what else? 2P, obviously, okay. Polynomial, how about polynomial? X squared. Are there any easier polynomial get evaluated to 0? X, right? Okay, and so on. So the claim is you can find this set of kernel using two generators P and X. Okay, so this is the claim. So let's prove this. Okay, let's prove this. So one direction is easy. Okay, one direction is easy. So obviously what? Px is a subset of curve. Okay, because what? If you take any linear combination of P and X, you will evaluate. Wait, can I do like this? I think I cannot say this. Can I say this? I can. So any linear combination of P and X will be evaluated to 0. Okay, under ring homomorphism. So A and B here could be what? What are the possibility of A and B you can take here? What are the possibility of A and B you can take? Where does this A, B live in? What are? Z, X. Okay, so it's ZX, not just Z. So for example, you can take A to be A squared plus 2, B to be X plus 2, something like that. Okay, for example. Okay or not? Okay. Okay, so you need to be careful where's the coefficient you take. Okay, which ring you take. Over it. Okay. So how about the other direction? So next, want to show curve phi is in Px. Okay, the ideal generated by P and X. Right. So how to show this? So you need to take any y in curve phi, and then show that this y can be written as a linear combination of P and X. But what's the general form of y? Y live in where? Domain or codomain? Domain, right? So what's your domain? Z, Zx, okay? So you can write y to be, let's say, y to be an x to the power n plus a1x plus a0 zx, such that what? Phi of y equals to 0 because it's living inside a curve. Okay, so now we're trying to write y as a linear combination of p and x. So let's try and determine what happened here. So note that phi of y is equals to what? Phi of y is equals to f0. Okay, so correct not? Okay, under this map here, f0. But f0 equals to what? A0 equals 0. Oh, I mean, yeah, sure, f equals 0. But what am I writing here? Sorry, do something wrong here. So can I change notation here so that we have a function to look at? Okay, so if you evaluate this polynomial at 0, what do you get? You also get a0 here. Okay, right now. So pick up the constant term inside of polynomial. But at the same time, you want this constant term to be equal to 0, 0 mod. Huh? dy 要改在哪里 ？Okay, thank you. So here change the y. Okay, so this means what? This means a0 is a multiple of p. Okay, good. This and that and p. Okay, therefore, how is my f looks like now? So I can write my fx equals to what? An xn plus plus a1x plus what? mp. Now what does this mean? You also can do distributivity law here, such that you can pull out an x from the first n-1 term here. N term here. First n term here. Okay, but what do we show here? So my f is a linear combination of p and x over zx. Okay, no? Okay, so linear combination of z and x. Any question? 原题吗？原题吗？原题吗？ So in this chapter, one thing to remember is when you take linear combination, you need to ask yourself where these coefficients live in, which ring they live in. Okay, which ring? Okay, 你要问你自己 ，OK， 你拿怎么样的 linear combination， 它的 coefficient 活在什么 ring 里 ？OK， understand? Okay, so you can see that these coefficients live in where? Z, Zx. Living Zx. Okay, this one also living Zx because it live in Z. Okay, Z is okay. Yeah. Any question? Okay, you want to? No. Okay. Okay. So another example I didn't show you last time. So let's look at this idea here. So let's look at ideal generated by s cube, x square y, xy square, and y cube here in C xy. Okay, so can you see that this ideal will generate polynomials, okay, in which every term has degree at least 3. So this ideal here will generate polynomial in which every term has degree at least 3. Or in this case here, we will call it a total degree because we add out the degree on monomial x and monomial y. Okay, monomial in x and monomial. Can you see it? So x cubed is degree 3, right? Y cubed is degree 3, but what is the degree of x squared y? Okay, so you add out the total of x and y. Okay. So this ideal says what are the general elements here? So the general elements here is a plus x cubed plus b plus x squared y plus c times xy squared plus d times y cubed, such that a, b, c, d live in the ring. Okay. Okay. It's one inside here. You like the word here. Is multiplicative inverse here? Sorry, multiplicative identity. Is it in there? Is one in here or not? Thompson? Yes or no? Yes. No. Yes. No. Yes. Yes or no? You think so? What happens if one exists in the ideal? Still remember? What happens if one exists inside your ideal? You can get all the elements in the ring. It's the whole ring. Okay, but this is the proper ideal here. Okay, so one is not here. How do you pick one? Do you have inverses? Not don't have. Okay, you don't have inverses. I mean multiplicative inverse, not additive. Additive identity you should have. Okay, but one is not in here. Okay, so I want to warning you again. Warning what? One in general does not exist in an ideal. Because why? If it exists in the ideal means what? If an ideal I contain 1, then the ideal I is the whole ring. Okay, it's everything. It's the whole ring. Okay, remember what would we call an ideal that contains 1? What do we call it? What's the name? Yes, this is a unique ideal. But remember last time what thing we call as an ideal? In C, what's the definition of unique? What's the definition of a unique? 什么？What's the definition of a unique?求救一下。蹲下旁边的会吗？后面前面。Unit. What's a unit? It's an element. What kind of element? Right? Has multiplicative inverse. Okay, meaning this element is invertible. So what kind of invertibility here is multiplicative. Okay. So so for example, okay, let's give an example here. For example, what is unit in let's say R? What a unit in R? For example, what is invertible here? What number has multiplicative inverse? 2, right? Okay, 2 half, for example. Okay, so what's the other way to build unit ideal here? What's the other way to build unit ideal here? So in R, right, you can see that actually the unit ideal is equal to the ideal generated by 2. Why? Why? This 2 ideal is the same ideal. Why? They are equal to R also. Can you generate 1 from 2? How? Multiply by 2. 2 multiplied by 2, you get 1. Half, right? So meaning what? If it is invertible, then you can find the multiplicative inverse in your ring, such that when you multiply them together, you get the multiplicative identity. Once you get multiplicative identity, then what? You can generate the whole ring. Okay, no? Good, and so as long as you have a principal ideal generated by a unit, it is a unit ideal. Why? Why? Because you can multiply this unit by its inverse to get multiplicative identity. Once you get multiplicative identity, you can get everything else. R times 1, you get everything. Okay, any question? You want to question? 问题吗？明白吗？ Okay. So the upshot here is you can form an unit ideal using a principal ideal generated by an unit. Okay. You can form an unit ideal using a principal ideal generated by a unit. Okay, so let's say like this, where M is invertible. Multiplicatively invertible. Okay or not? Okay. Yeah. Okay. Any questions so far? Any question? All right. So let's continue. Proposition. Let's start new. So let's start proposition. So the only ideal of a field. Okay, so this is a very interesting property about field. The only ideals of a field are the zero ideal and unit ideal, meaning you cannot find any proper ideal in between these two. So 什么意思啊？意思 就是你是0和1的游戏。Okay, only 0 and 对啊对啊0和1的游戏。You only got 0 or 1. Okay. Either you have 0 ideal, either you have everything. Okay, for a field. Okay, for unit ideal. And we have a converse here. We have a converse here. If a ring that has exactly 2 ideal, then it is a field. Okay. If a ring has exactly 2 ideal, it is a field. Okay, so we have a kind of a converse here. If you found out that your ring only has 2 ideal, then it is a field. Note that I didn't specify which 2 here, but obviously 0 ideal and unit ideal will always exist in your ring because you always got 0, you always got 1. Okay, so all right, let's prove it. Okay, let's prove these 2 interesting statements here. Okay, let's put them. Okay, let's prove the first one. Okay, so obviously 0 ideal and unit ideal are ideal. We have proven before. So suppose that, okay, so if you want to show that there's only 2, right? How do you do it? Suppose there's another one. Okay, suppose that has an ideal I other than the 0 ideal or the unit ideal. Okay. Then what's the strategy here? What's the strategy here? If you tell people there's only 2 things here, they don't believe how to prove to them. So you take the third one, show to them that the third one is either the first one or the second one. Okay, so we will do this strategy. So suppose that f has an ideal I other than 0 and 1, then we can find a non-zero element inside I. Okay. We can find a non-zero element inside I, which is not 1 and also which is not 0. Okay. And also x is not 1. Okay. Somewhere between 0 and 1. You see, this is a non-zero element in F means what? 什么意思, Eugene? What does it mean by a non-zero element inside a field? What's so special about non-zero element in a field? What's the definition of a field? Sorry? 什么？忘了，找一下。现在可以忘，考试不能忘，不然你就忘不了，你就一辈子都忘不了。北中有卡皮巴拉。来，韦德呢？韦德 ，non-zero element inside the field means what? What's the definition of a field? 去找。常言 non-zero element inside a field means what? 找啊！来，下一个是加一吗 ？Non-zero element inside a field means what? ？Means what? Non-zero element inside a field. See? It's a unit. Good. It's a unit 什么意思？啊，云溪刚才说了 ，is a unit means what? 有 multiplicative inverse. Okay? So x is inside this ideal. Means what? You can make the inverse x and multiply inverse to x. Then x inverse times x is inside the ideal. But what is x inverse times x? Huh? This is. So meaning what? Meaning 1 is in the ideal. So I is everything. Everything is what? The unit. Okay. Yeah. Okay. Okay. All right. How about next one? A ring that has exactly 2 ideals is a field. So to show it's a field, what do you need to show? Definition of a field. Definition of a field. Okay. Anything else? Then it is just a commutative ring, right? It's just a ring. But here's a field. Is field equivalent to ring or not? So what's the difference between field and ring? What's the difference between field and ring? User, what's the difference between ring and field? Hmm? 找，去找。来，宇轩啊，宇轩，我不懂，找啊，找啊，没有不懂的，你一定要跑出来。找到了吗？是不是？Ian, what's the difference between ring and a field? So every non-zero element in a field has multiplicative inverse. So what do you need to show here? You need to show that every zero element, let's call this ring R, okay? In R has a multiplicative inverse. Multiplicative inverse. Means what? This one go back to your group. Means what? There exists an x inverse such that x inverse times x equals to identity equals to x inverse times x. Okay, so go back to your group theory. Which one? Right. So what to do here? So you know about something about ideal, right? Okay, you know something about ideal. Now you have an element x. So what can you do here? Huh? What can you do here? You make the elements into an ideal or not? Huh? Can you build ideal from elements? Huh? Hello. Can you build ideal using elements? 怎样 build？ 好 the principal ideal. Okay, principal ideal. X. But note that in this string only has two ideal. Only has two ideals. Okay, so what sort of two ideal can exist here? Okay, note that R only has ideal generated by 0 and also generated by 1. Okay. This two must exist first, right? Okay. But if it is only two, then must be this two. Okay, so the question is, the ideal generated by X can be 0 ideal or not? Can or not? Cannot. Cannot, right? Why? 0 ideal got how many things inside here? One thing, which is 0. But here got X and 0. Okay, so in this case here, so in this case here, so the only case would happen is the ideal generated by X is the ideal generated by 1. Okay. Is this enough to prove or not? Can you find X inverse? How? To find X inverse? 什么叫等于1？可以直接这样等于吗？可以这样吗？可以，不可以 ？Obviously 不可以啦，我刚才都给你看了，我不给你看了咩？这个2等于1啊，你会被你的小学生打死去。2等于1，不可以？那可以？2等于1啊？说怎么办？打叉 ？OK， 打叉还是删掉？叉 OK。说怎么办 ？X live inside the principal ideal means what? Since S live inside the ideal generated by 1, there exists a R in your ring such that R times X equals to 1. But your ring is also commutative. So R is the multiplicative inverse for X. Okay. Okay. So we just keep using the linear combination definition only. Okay. So be sure that what this generating ideal means. Okay, we still got time. Let's go. Continue. Corollary here is this is a very strong result. Every homomorphism, ring homomorphism from a field to R. Okay, usually we write field like this. Okay, it's a math BBF. Math BB, right? Yeah, math BBF from a field to a ring is injective. Okay, still remember how to show a ring homomorphism is injective or not? What is the equivalent property? Kernel of the ring homomorphism is 0. Okay. So let's put a proof here. So what is the kernel of this ring homomorphism live in? Domain or codomain? Domain, right? Okay. So last time we also showed that kernel of a ring homomorphism is an ideal. It's an ideal or not? It's an ideal, right? Okay. So how many ideal in a field can exist? 2. So what are the ideal? But only 2 ideal will exist in the field, which is 0 ideal or the unit ideal. Wait. 来干嘛 ？Okay, sorry. So this one is 那个也不对啊，这个也不对啊，这个不是 R，sorry 啊，你们注意一下啊，有时候我的 ring 会跑偏了，你要注意一下，有时候这个是 real number， 这个是，对，你们注意一下啊，来注意一下这两个东西，看我是不是要讲 real 还是我要讲 any ring，OK， 注意一下这个东西，有时候会写错，很常写错。Okay, so but only 2 ideal exist in field. So if curve phi equals to 1 means what? So sorry, if it is equal to ideal generated by 1 means what? 啊 ？Invertible？ 为什么 invertible? So kernel of phi equal to 1 means what? How many things you get sent to 0? Everything, eh? So if you send everything to 0, meaning what? Phi is a 0 map, no? Okay. But what do we say about 0 map? Can 0 map be a ring homomorphism or not? Can 0 map be a homomorphism or not? Did we talk about 0 map? 啊？我也有印象，我有讲过，这个在哪里？上在哪里？在 lecture 几 23 23哪一个 slide 啊？有没？啊？16页？lecture note。lecture note 啊 ？lecture note 有吗？16，1、2、3、1、2、3、4、16，这个。A 0 map is not a ring homomorphism unless your codomain is a 0 ring. Okay, we showed this before. Why? What does a ring homomorphism have to satisfy? Yeah, phi A plus B equals to phi A plus phi B. Phi A B equals to phi A times phi B. One more. You need to which identity? Multiplicative identity to multiplicative identity. But if it is 0 ring, you cannot reach the multiplicative identity unless the additive identity is equal to the multiplicative identity. Okay, but if it is non-zero ring, they are not equal. Okay, so but 0 map is not a homomorphism. Okay, when R is not a 0 ring. Okay, therefore what? Left only one possibility here. Okay, 只有一个可能性啊。Kernel of phi must be the 0 ideal. So this implies that phi is injective. Okay, so this is a very strong result. Whenever you have a ring homomorphism from a field to a ring, that homomorphism must be injective. Okay, injective. The concept of injective is very important in mathematics. So to prepare you to topology. Okay, so injective is very important here. So how you think about injective? So injective means if you have a map from F to R, it will still as itself. Maybe you will change shape, but you will retain everything you had before. Okay, injective. Okay. So let's say if you have 5 items inside your field, after you map into the ring, you will still have 5 items here. Okay. Okay, so you are, for example, okay, you inject into this class. 有没有？懂没？什么 ？No no no，I mean you inject into this class， 是不是？有没有说你跑进来这班上过后，你的手跟脚变一样去？没有吗？对不对？你手还是手，脚还是脚嘛？对吗？对不对？没有被 identify 啊，对不对？Okay， so you are like an injection into this world， 你被 inject 进来，你被你的父母 inject 进来。Okay or not? Yeah, if it is not injective, what happens? So maybe what? Maybe everything gets sent to 2 point only, maybe. Okay, if it is, this one is not injective. Okay, so if it's injective, then you will retain yourself. 这懂没？应该有扣懂没？应该有 bigger space. Okay, no? Okay, so field is very important. So for example, what kind of field you have? What have you seen? What field you have seen? Field. Calculus. Analysis. What field? Scalar. What scalar you have? Huh? Real number. And then? Complex. And then? Rational number is a field. Okay, they are multiplicatively multiple. Irrational. Irrational is a ring or not? Is it a ring? Why is it not a ring? Multiplicative identity is rational or irrational? Rational. Yeah, so if you remove it, then you don't have multiplicative identity. Huh? Yeah, but book close. Also zero, also rational, not irrational. Okay. Okay, maybe we quickly write down, maybe it's useful for you. So what sort of field you can see? Real, complex, rational, and then anything else? Maybe you can take GLN union with a zero matrix. Okay. Okay, let's say this is a non-commutative. Oh, 对对对 correct, thank you. 是吗？ Yeah, 是。Okay, 好 thank you. Okay, something like this. 这样如果 GLN Z2 GLN Z2 GLN Z2 可没有呢 GL2 Z2 可没有呢有没有呢可没有有块块的例子吗有没有例子 GL2 Z2 不可没有 does not compare GL2 Z2 any quick example 来想一想回去想 Okay. Right. Okay. So I think we can break here. So let's break until 6:59. Sorry, 5:59. 5:59. 5:59. Okay. 哪个？
你刚说的那个 GLOF，顶上一个零加法不 close。
哦，会加粗。
对啊。
OK， 好吧。
这个我还没想出来。啊，顺便我想跟你说，factorization 是不是应该是个 Z 不是 S？
应该是看英国还是美国吧？
我看如果是加 S overleaf 会给你加红线，然后是 Z 就不。
因为 overleaf 可能是美国或者英国的。
那我就用
Microsoft 也是这样吗？
我用 Z 的可以吗？
可以啊。
还是你喜欢？
我觉得 Z 是英国诶，美国是 S。
美国应该是 Z 的。
我觉得 Z 是英国。
我查一下。
这样查。
因为我查一般好像我都是 factorization。
A 是英国不 ？X 比较常喜欢用 X。
你们学的是 S 呢 ？S 应该是英国的。
对啊。
是英国之后。
对，看清楚看。
overleaf 只有 Z 不会画红线。
因为那个反正UK 才是 S。
哦。
OK。
还有那个什么，
因为有时候是动词，有时候名词就是 Z。
你去检查一下你的上节课，你有很多个下标应该是零的，你从1开始了。
下标
这个嘛，下面应该是从0开始的，你从1开始了。上个课件。我先来的。你去看你的 lecture
这个这些。
这个是对的，但是你看有很多个地方应该要从1开始的，你是从0开始的，你从1开始了。然后这。哎，我刚看见不知道在哪儿了。
我排队先。
不考没了，不考没了。
你哪来的2Z 那个里面？
哦，零啊，有零啊，OK， 好 ，OK，
我怎么找不到了？
谢谢。
刚刚看到好多个。你要跑，你先问你吧，我找到了，我跟你说。啊，还要再上一节课了，我说。
有一个东西。是哦，个 B 等于1嘛，unit ideal，then B 等于0，什么意思哦
？Total 是所有东西什么意思？把所有东西都上去0。是啊。然后就是把所有东西上去0。这个是 Polynomial 就是把所有东西上去0。
这是不是你上传的东西？
是吧？不是，怎么可能？是吗？有3种错吗？
没。
整个 view， 代表你的 kernel 是整个 view， 所以代表它 set 东西是0，进行也是。
哦，这个地方，它应该从0开始的，你从1开始了。
那你看 zero map 不是？
还有嘞，
好像有几个这种小地方，但是我不一定马上能找得到。
像
我也能打它。
对，好像就是这一页，基本上
就没有。
基本上是
导用的。
是，因为你这个地方直接都不写了，我也就没打了。
你没打？
这个 sigma 你要让我上下边全加上，累死人了。
哦，我会讲你那个 proof 没打。
我打了，是说上下标没打，因为你这个地方 sigma 不是就直接 sigma 吗？大家都看得懂。好像就这个地方。
如果 map 全部给升级0了，还有别的错？没有，还是讲这么 zero map。
哦。
因为他没有
ring homomorphism 定什么？
全部是0了，全部都
你这个要改了。
改了，我改了。
我的 domain 没有
domain 的升级0呀。
然后
哦，所以idea 是不是一定是个 run？
idea 一定是 run 吗
domain 是靠 domain。
靠 domain 没有。
我做了一个脑子，我觉得应该是。
是整个 view。
unit
啊，就整个 unit
太简单。
整个 view
是
0，但是我的 domain 没有 identity， 但它就不是我。
我感觉是。
你拿domain 里面的 multi 什么 DB 给 identity 升去0
啊，
那就
其实我来讲什么？
所以为什么是 multiply multiply
条件。
对，条件。
什么 multiplicative identity 双线 multiplicative identity。这个
有你做嘞，
那讲
什么？
肯定肯定要 b 等于0，意思讲之前整个东西，整个 build。
昨天你不是去吃巴布点？
不，
然后跑过来我讲哦，
车里放什么了？
then 它就在这个是
对，我要礼拜才交，谢谢。
真的没？
你要什么？
真的？
build 送去0，
真的
build 送去
？OK。
build 送
我
去
打美美。
你说你要什么彩椒？
build 送
反了呢？
反了？
反了也是可以。
这个时间
100
build
110。
build 是送去0 build 送去0。
点名。
所以我的 B 是0，我刚刚0送去0。B 等于0。
哎，110怎么在它里面了
100哎，110不 input。
？110不在它里面啊？
哦，是。
有，但是110怎么又从来？是啊，是吗？哦，就是这两
这里是1的话，
我懒得确认。
那个是 identity， 那个是 identity。
等一下，那个
小羊。马上看到。
我的或者那个
红杰这么小吃掉了。
都没
红杰。
就是感觉是哦，就是因为
今天不是我骗他了。
规则。
跟他讲啊，
哦，这个
我这你知道我们上个星期三换课时吗？昨天。对对对。你没有来，你是没有来。哦，对对对，周2。我们换课是因为就换去隔壁，因为那个麦不好。好，你没来啊 ？OK。子涵有在吗？子涵。曾子涵有在吗？曾子涵没在。
也是，
那在不在？啊？
可是不可能，
在一个
把这个变1了哦。
B 就是我的0啊。
这个
哦，
哦。
我是哪一个家庭？
哦，
我是哪一个家庭？
你是参加零啊？
就是你们叫穿的是真的。你不信讲电我，他也是那个穿很重的。
哪个？
说马了。陈子豪 ，OK。
1是什么？
带一层呢？好像我看到他不是带一层，该我教他带一层。恶心。冰箱没有在哦，他们去哪里？去夜市啊？有懂懂？
因为周一班晚上排舞吧，好像。
拍什么舞啊？
我不知道在 B1 表演
啊
有一个
？B1表演。
有一个 event，
OK。哦。
会有表演。
谁呀？谁表演的？
钟一帆。
哦，钟一帆。他跳舞。他跳舞社的。
对啊。
哦。小。
来再一次。
孙佳也是。哦，孙佳也是后面。方宇。汪家有在，苏雅有在。
这个东西。
真哦。
E 跟 A 都是 Epsilon。
那个有理由一个。
哦，E 是有理由。
赵瑞呢？赵瑞呢？
他不是他。
啊。金鹏。刘金鹏。刘金鹏呢？刘金鹏。也跳过去。
不会6节课缺到6节课以上就直接给他这样。
Okay, let's start. 快乐时光总是特别。
有时候是啤酒哎，死的那一瞬间。
怎么忽然间讲死 ？Okay, so let's continue. Okay, so still remember, remember what's all the subgroup of Z? Subgroup of Z is what? Huh? Subgroup of Z are what? What are subgroups of Z? Integer. That is what kind of group? What's the property of integer group? Abelian. Anything else? It's generated by how many elements? 1. So it is a cyclic group. So all the subgroup of a cyclic subgroup must be cyclic. Okay. So similar here, the ideal in the ring of integer are also principal. Okay, so they are principal. But why are they principal? Because they are from the subgroups of Z. Okay, and they are principal. Ideal. So it's the same as so you should. What's the analog of a principal ideal in group? It is a cyclic subgroup. Okay, generated by one element. Why is it a subgroup of Z? So when we talk about subgroup here, what kind of group? Group under addition. Okay, group under addition. You know. Why ideal have to be a subgroup? What's the definition of an ideal? Why ideal has to be a subgroup? Close under addition. Okay, ideal have to be close under addition. Also close under taking multiplication with your ring element. Okay, any ring element. So it is a additive subgroup here. Okay. So let's do proof. So I put 3 versions of proof inside my notes. Maybe we will show 2 of them here. So first one will be the easier one. So let's do the version 1 first. What's the version 1 proof here? So all ideal in Z are additive subgroup of Z. Okay, why? Because ideal are close under addition. But what do we know about subgroup of Z? Every subgroup of Z must be what? Yishan. Every subgroup of Z must be what? Must be what? We just discussed 5 minutes ago. Must be? 听不到？什么？先听不到？不知道？哎，隔壁，是不是？又不知道？什么？就是叫什么 ？Sorry，可以再大声一点声，没听到。是什么 ？Principal ideal？我们要证明嘛，对不对？所以现在要 subgroup of Z。How to describe subgroup of Z? Z is a cyclic group. So every subgroup of a cyclic group must be what? every subgroup of a cyclic group must be cyclic. 懂什么意思吗？什么意思？说说看。你先重复我讲什么？刚才。OK， 什么意思？里面的元素，元素是 cyclic 是什么意思 ？subgroup 还是元素？哎，错，意思错。就是呢 every subgroup of a cyclic group must be cyclic 的意思是什么 ？cyclic group 的意思是什么？啊 ？cyclic group 的意思是什么？是吧 ？An element. Okay. Every subgroup of a subgroup that generated by the element must also be generated by one element. 每一个 subgroup 只能够被一个东西 generate。OK 吗？一个东西 obviously 是可以 generate 一个 subgroup 的，但是这个是比较强的。每一个 subgroup of a cyclic group also generated by one element. Yeah. Okay. So every subgroup of Z must be cyclic. Okay, must be cyclic. So this implies what? So this implies that ideal of Z must also be generated by one element. Why? Because ideals are also subgroup. Okay, ideals 一定是个 subgroup. Okay, because ideal close under addition. Okay, it must satisfy subgroup property. So this implies that they are principal. Okay. 有问题吗？问题吗？ Any question? Okay, so let's do a second proof. Okay, this second proof will use a number theory result here. So we will use a number theory result here. So let's do a second proof. Let's take the least positive integer p in I. Okay, and we will show that the ideal is simply generated by this number p here. Okay, how do we pick? 找得到吗？这个东西 Actually, we need to assume well ordering theorem. Okay, or maybe Zone's lemma. If you go topology, you'll see this. Yeah. And then axiom or axiom of choice. So they are actually equivalents. All of these can be proven they are equivalent. What is well ordering theorem? So a very wide use theorem in, for example, natural number. If I give you a subset of natural number, okay, you should be able to find the least positive number there. Okay, 你可以找最小的那个号。Okay, not. It is not true, for example, where is it not true? In Z, not every subset of Z you can find the least number. For example, even number, you cannot find the least one. Negative 100, you still can find negative 102. And find the least one. Okay. So for this I, you can find one for this least positive integer. Okay, not here, least positive. I didn't say least integer. Least integer, you cannot find one. Least positive one. Okay, least positive. The one after 0. Okay, the one after 0. If we cannot find means what? If we cannot do this, there's one thing could happen. Okay, if we cannot find this non-zero positive p here, someone is hungry. So if you cannot find p, then we are done also. Why? Because this I is simply the zero ideal. Okay. Maybe you ask a question. How about, could it be inside the ideal all negative number, no positive? Is it possible or not? 有可能吗，嘉玲？有可能啊？有可能吗？ Is it possible? Right. So is it possible that my ideal, the ideal I take, only consists of negative integer, no positive one? Is it possible? No? My claim is not possible. Why? Once you have negative integer here, what can you do? This is an ideal. You can multiply by -1. So you get a positive one. Okay. Okay or not? Okay, ideal must be close what? Undertaking multiplication with any ring elements. Okay, if one exists, obviously -1 should exist. So guess what? -1 is a ring element. We can multiply. Okay. Right. So we want to show that I is generated by P, meaning what? Meaning what? Every element in I is a multiple of P. So whenever we think about multiple of P, how to prove this? We should always think about division with remainder. So if you can divide, meaning what? The remainder has to be 0. Okay, so this is what you have to show. So let's say, suppose there exists an x in I, which is not a multiple of P. Okay, suppose there exists a number which is not a multiple of P, then what? Then by a famous result in number theory, which we call the Bezout identity, or what's this Bezout identity? This is just the inverse Euclidean algorithm. What does the Euclidean algorithm do for you? What's the? Do you still remember? What does the Euclidean algorithm do for you? Euclidean algorithm 可以找什么东西？ GCD, good. Okay. So if you use this Euclidean algorithm, then there exists R and X in Z, such that R times X plus X times P equals to GCD of XP. Okay, note that GCD of XP should divide P and X. Okay, in particular P. So this means what? GCD is always less than the less than or equal to the number that you divide. Okay, but what? But S is not a multiple of P. So meaning what? P is not a factor of X. Okay, P is not a factor of X. So can GCD equals to P or not? GCD of XP can equal to P or not? Cannot, right? Because P is not a factor of X. So it cannot be a divisor of X. So GCD of XP must be less than P. Okay. But what did I do? How do I write this GCD? This is a linear combination of what? S and P. But S is inside my ideal. P is also inside my ideal. So meaning what? Ideals close under taking linear combination, right? So this implies that GCD of SP live in I. So there's a contradiction here. Where's the contradiction? Where's the contradiction? GCD of XP live in I. GCD of XP less than P. P live in I. X live in I. What's the contradiction here? P is the least positive, but you found someone smaller, which is positive also. Okay, so there's a contradiction here. And we got a contradiction where the existence of GCD XP contradict the minimality of in I. Okay, you found someone smaller. 哎，韩星，什么问题？要跑去前面吗？这个，这个 ，this is by assumption，对不对？ Okay, if every element in I is a multiple of P, then 我们就解决了。Okay, but we suppose for a contradiction. Okay. So this Euclidean algorithm always work for two integer. Always work, right? Yeah, always work. Okay, you can always find GCD between two integer using Euclidean algorithm. Ah, 还是要帮你温习一下讲用 Euclidean algorithm，不用了。啊，你问题是什么？来，快点，再给你1分钟。再给我2分钟。啊？反正是。下还是上？上去。什么？啊，对对，没有错。啊，对。我到最后 prove 到的是没有 x， 没有 x 不是 p 的 multiple。所以这样是有还是没有？哎，没有 x 不是。全部 x 都是。你给 double negation。double negation. There does not exist an x such that x is not a multiple of p. So meaning every x in I must be a multiple of p. Okay. Okay, ma. Okay, so let's continue. All right. So we can generalize this idea. So in particular, every ideal in the ring of fx. So ring fx means what? All the polynomial one variable x over where? Over a field. Okay, over a field F is a principal ideal. Okay, so you can think of it like fx is like z. Okay, z is a all the ideal in z is principal ideal. Okay, what's this? Like that. Someone is that. Yeah, ideal. So so fx also the same. Okay, even though you adjoin an x there, it is principal also. Okay, so every ideal you found, you can find a generator. This result is quite strong. Okay, you should think about idea is like a bunch of things, right? All the linear combination, but only generate by one element. Meaning what? That generator can divide every element. Okay, inside your ideal. So what's it? So you should interested in this single generator here. What's the generator should what sort of generator is it? So this generator is a monic polynomial. Still remember what's a monic polynomial mean? The leading coefficient is 1. Okay. So what unique monic polynomial here? This is the one that has the lowest degree. Okay. All right. So let's prove it. First of all, let I be an ideal in fx. Okay, we want to show that it's principal. Well, I mean, we should suppose that I is not the zero ideal. Otherwise, we are done. Okay, are we done or not? Okay, why are we done if it is a zero ideal? So not zero. Why are we done? This is I and not 1. 敲起来了. Otherwise, we are done. Okay, if I is a zero ideal, who is the generator? 0, the zero polynomial is monic. It's not monic. It's not monic. Yeah. Okay. Let's see. Okay, so it's not 0. Then let f be a monic polynomial. Okay, with lowest degree. Right. So we want to show that I equals to the ideal generated by f. We want to show this. Okay, so two directional, left to right and right to left. Okay. Right to left and left to right. So which direction is easier? Left to right or right to left? This one you need to pick from I. Sorry, I just have to pick from I. Sorry, right to left is easy, right? Because f is already in I. So all the multiple of f should live in I. Okay, so clearly ideal generated by f is in I. Okay, so you need to show the other direction. So to show the other direction, what do? You pick any element in I. Okay, you want to show that can be divisible by f. So you need to do some sort of division with remainder. Can we do division of remainder or not? This is a polynomial ring. Okay, we can do division by remainder there also. So we want to show that equals to f, let's say q prime for some q prime in fx. Okay, so by division with remainder, what do we get? We should get an extra remainder there. Q equals to f q prime. Why I put q prime here? Not need q prime, like q is enough to differentiate. plus R. Okay. Such that what? Sorry, 什么？ 哦，sorry 啊，so 哪一个方向？这个是 G 吧？呀，这个是 G。什么？什么东西？哪里？啊，对对对，啊对，没有错，我们要正2.0，对，没有，刚才他是说我的 Q， 我 Q 写2次，什么问题 ？OK， 没有，刚才我的写错这边，那个 G 往后翘，你不要往前翘，对不对？也敲错边，sorry 啊。OK， 哦，好像我记得我妈以前讲我 B 这样写，反掉。喂，怎么有病？喂，哎，怎么有病？哎，你去幼稚园看大把的 B 是怎样的，你知道吗？I mean，为什么天生 B 要这样？没有理由的嘛，对不对？I mean，这 definition 吧。I mean，我去火星，可能我把 B 变成这样。啊？俄语啊 ？OK，interesting。OK， so by division of remainder 有什么可能性 ？Either r equals 0, then you are good, or the degree if r or if r is non-zero, then the degree of r must be strictly less than degree of f. Okay, the one you divided with. But again, so 这个是 trick 啊。This is the trick in ring. Okay, what's the trick? Linear combination. Okay, so what's the useful linear combination here? Note that we can write R as G minus F Q. Okay, how we pick this G? This G we pick from where? I. Someone else also from I. F also from I. So I write R as a linear combination of thing inside I. Meaning what? This R have to also live in I. Contradict what? If it is non-zero, then the degree of R less than degree of F, but I assume that degree of F is the minimum one. So there's a contradiction. Okay. Now then, right? So here we got a contradiction if R is not 0, since degree of F is the minimal positive. Is the minimal positive. Yeah, that's all. So R must be 0. Okay, so R must be 0. Okay, otherwise we get contradiction. Okay, so how to prove uniqueness? How to prove uniqueness? I start from first day, day 1, day 2. How to prove uniqueness? Suppose there are 2 of them. Okay, suppose F1, F2 are 2 monic polynomial of lowest degree in I. Then what can you do? Then you can take their difference. Hey, there are 2 monic polynomials. What's the difference? It's another polynomial. Okay, it's another polynomial. In particular, what's the degree of this polynomial? Must be less than. Okay, having lower degree than who? Let's call this lowest degree n. There must be lower degree than n. Because they are monic, right? So the highest power one should cancel. Okay, should be less than n. So meaning what? Meaning what? Meaning use the same logic just now. Meaning what? The difference has to be 0. Okay. 为什么？为什么 ？F1 跟 F2 已经是最小 lowest degree 了，你还可以找到另外一个吗？不可以啊，对不对？不可以吗？所以就一个可能性，它是对，对吧？如果有的话，那它就是新的 F1 F2 OK， 你不可以这样无限找下去的，你不能无限找下去，你无限找下去，你不要 limit 啊，没有 limit 啊，那都不 calculus， 应该没有 limit 的。OK。Okay, no. Okay. So yeah. So the monic polynomial of lowest degree is unique because f1 equals to f. Okay. 有问题吗？ Any question? 有问题吗？ Any question? Okay, let's go for one example, one lemma, and then one corollary, and then we go to assignment. Okay, we start quotient ring next week. Come on. Okay, let's continue. So let's look at this ring homomorphism here. So this is on coefficient, and then there's a ring homomorphism from the polynomial ring over rational complex. Okay, so what do I do here? I send x to √3 of 2. So can you guess the kernel of this capital phi or not? What's the kernel of this capital phi? 来猜一猜有什么东西躲在这 kernel 里面？猜一下有什么东西躲在这 kernel 里面？ What's the polynomial that evaluate to 0 in this map? What polynomial evaluate to 0? S 减 S 减 cube root 2啊，有可能吗？这个东西会活在你的左边里面吗 ？Cube root 2 is irrational. So how? So how? What's inside this kernel? S cube minus 2. Good. Okay. So the claim is this kernel is generated by this polynomial here. Remember, Q is a field. So just now we proved that every ideal in the polynomial ring over a field is principal. So we try to prove that this kernel is principal ideal and then generated by S cubed over minus 2. So just now we proved what? It must be generated by a monic polynomial of lowest degree. Is it lowest or not? Is there any S square polynomial? Okay, degree 2 polynomial that evaluate to 0. Is it possible? Okay, so we need to prove this. Okay, why is it not possible? Okay, so let's do this proof here. So if this is the lowest one, then we are done. Because last theorem tells us that it must be generated by the monic polynomial that has lowest degree. Okay, so this is monic already. So we need to prove that it is lowest degree. So suppose, so let's do the proof. Suppose on the contrary that this is not the lowest one. Okay, so suppose that fx equals to s cubed minus 2 It's not the lowest polynomial. It's not the lowest degree polynomial. Maybe add a monic word also, monic. Lowest degree monic polynomial such that f of cube root 2 is equal to 0. Then what? Then you need to check all the polynomial that is degree less than 2. So meaning what? There exists a, b, c in rational such that what? Phi of ax squared plus bx plus c equals to 0. Okay? Okay? Which means what? You can write down a linear combination of 2 of 2 over 3 plus b of 2 plus c equals to 0. Okay, is this possible or not? Is this possible? 可以吗? Is it possible? So where is this ABC from? These ABC are from rational. Can you multiply some rational number to this irrational number and then you get 0? 对没？怎么知道？ Huh? So meaning what? You want to show that these 3 radicals here, maybe 2 of them, and then 1 is 1, they are linearly independent over rational. Right? So if we show that a equals to b equals to c equals 0, then we are done. Okay. If not, then you found a smaller degree polynomial that evaluates to 0. Okay. So we'll put here. So we want to show that a equals to b equals to c equals to 0 instead. Okay, how to show? How to show? Okay, go back and show yourself. Okay, go back and show. I will put answer in the lecture notes. I don't want to go into this linear independent proof. Okay, I write down in the lecture note already. So you should think about it first. Okay, if you cannot figure out, you can look at the lecture note. This is like a linear algebra proof. 叫阿丽来。Hello, Ali. Ali. Call out Ali. Okay. Okay. So 看一下还有什么。Okay. 快。来。So okay, let's do one quick quiz. 来给你一个 quick quiz. So let R be a ring. And if X is in R, what is R adjoint X? So what's a polynomial ring, okay, of R over X here? What do you think? What is this? Polynomial ring over X. What do you get? X is inside R. R 罢了. Oh, R 罢了. So why? Again, you need to show 2 direction, right? So which direction is easy? 右推. So R in R polynomial over R X is easy. How about the other direction? How about the other direction? So why is it true that Rx is a subset of R? So what is Rx here? All the linear combination of what? Power of X. Are they in R? Why? And also, yes, because R close under addition and multiplication. Okay, no? Okay, huh? All right. This one is very useful later. This one very useful later. So let's quick. Quick. Emma. Let f be a monic integer polynomial. Like why integer? I know why is an integer. So this integer means that the coefficient is over integer. So meaning this f live in zx. Okay, and then g also live in zx. Then the claim here is if f divide g in the rational, then f will also divide g in the integer with integer coefficient. I think this is the first thing. If you take abstract algebra 2, you will learn this. You will learn this again. Okay. Our theory. Okay. All right. Let me think about this. Why is this significant? Why is this significant? What do you think? Do you think this is obvious? Or this is trivial? Which side is easier to divide? Q. Right, because rational is a field. You can have multiplicative inverse for your coefficient. But Z is not always true. Can you divide 2 in Z? Right. Okay, but the result is quite kind of strong. As long as you can do division, okay, you can divide in the coefficient ring rational, okay, rational coefficient ring, then you can divide in the integer coefficient. Okay, so how to prove this step? So division, right? Whenever we talk about division, you should straight away link to division with remainder. Okay, so let's see how we're gonna use division with remainder here. So let's start. Since f is monic, okay, what we can do? We can do division with remainder. Okay, so we can do division with remainder. In where? So our goal is in zx. So let's do it in zx. Okay, so our goal is in zx. So let's do it in zx such that g equals to fq plus r. And then our goal is to show what? R is equal to 0. Okay. We want to show that R is equal to 0. But if we write these things, so this whole thing live in zx, right? In particular what? In particular what? This equation also is the same living in Q. Yes. Okay, because what? Because Z is a subset of Q or a subring of Q. Is it a subring? Yes, it's a subring of Q. Okay. But if you regard this equation in Q, X means what? R has to be 0. Because if you do division with remainder in QX, F can divide G. Okay. So in QX, F divide G. Okay, so R equals to 0. So you just transfer the information of R equals 0 from QX to ZX. So what's the overall process here? You divide it in ZX, but this division with remainder is just an equation in QX also. But if it has to happen in QX, what does it mean? The assumption says that F will divide G. So R equals to 0. So the whole thing will validate ZX also. Okay. And and what? So F divided G. So what's the moral of the story here? What's the moral of the story? Okay, 总体来说是什么意思？我在 ZS 做除法，跟我在 QS 做除法是一样的，明白吗？ ZX is more restrictive than QX。如果 QS 除得了 ，in ZX 我也除得了。Okay, ZS is more restrictive than QX. If you are divisible in QX, then you are divisible in ZX. Yeah. So this is the moral of the story. Okay, let's quickly bring out this corollary here. Maybe we don't want to prove it anymore. So what's the corollary here? So the corollary here is, hey, no need to let you see this. Let you see a larger one. You see this. Okay, so the corollary is this. We can have a integer theory for your field. Just now, I mean, for the polynomial ring over a field. Just now I show you that both integer and polynomial ring over field has principal ideal only. Okay. With this, we can do the similar thing as integer. Okay. So what happened in integer? Between two integers, you can find the GCD. So for two elements in the polynomial ring over a field, you also can find their GCD. So what's the GCD here? So if you consider the ideal generated by two elements and then you add them up, it is still an ideal. Then that generator, we will call it GCD between F and G. Okay or not? Okay. And then obviously D will divide F and G. And if a polynomial divide both F and G, it also divide D. Yeah, this is a property of GCD, right? GCD property is what? If you have another divisor that can divide two numbers, obviously it will divide the greatest common divisor. Why? Because GCD is the greatest one. Okay, greatest common divisor is what? Is a product of all the common divisor, right? Okay, so if you can divide both of them, you must divide GCD also. And then this one, this is the polynomial ring version of the Euclidean algorithm. Okay. Okay. So polynomial ring. So okay. So the conclusion is upshot. Where's the upshot? So the upshot is the polynomial ring over field is or has similar property with Z. Okay. So all their ideals are principal, and then you can find GCD between two elements. Any question? Any question? No question? Okay, let's go to correction for your assignment 4 before you hand in your assignment 6. Huh? No, assignment 4. So assignment 4, there are only 2 questions, but you guys didn't dig well. I'm not sure why. 时间太赶了，太难，考试太难。难是正常的，只能说。But 只会越来越难嘛。没有，人生就是这样的嘛，对不对？人生是这样，对不对？ Yeah. 人生起起落落。Okay. Right. So okay, 2 questions here. So let's discuss about the question first, and then we will briefly talk about the result. Okay, first question, what do you need to do? The question asks you to determine 6 subgroup in S4. Okay, we're referring to a homomorphism from S4 to S3, the one that we discussed last time, or you can find in your textbook. But this subgroup have to contain the kernel K. So what you have to use here, you have to use the correspondence theorem. Okay, so if you mention about correspondence theorem, you will get about half of the mark. Okay, with the right subgroup. Okay, if you don't have any step. So how to get the other half of this question? You need to tell me. Okay, you need to tell me how you compute this subgroup. Okay, you need to take the inverses. Okay, you need to do the inverses, and then you need to tell me why after you take the inverse image, they form a subgroup. Okay, and then you need to tell me why is the correct subgroup to pick. Maybe you can use order to check. Okay, maybe you can check their order. Okay, depend on how you phrase it. Okay, depend on how you phrase it, but you need to justify why this 6 set is the subgroup that we want. Okay, you need to justify. So a question like this, if you are studying in like this kind of pure maths class, find 6 subgroup, determine 6 subgroup. Don't just find me 6 of them. You need to justify why and how you found them. OK 呢？然后解释啊，不是写6个出来就解决啊。你要告诉我你怎么算的。You need to tell me how to compute it, how to verify， 怎样去检查。OK, how to check. OK 呢？ So basically, by the correspondence theorems, right? You need to start with a 6 subgroup in your codomain. So some of you do extra stuff. You show that there are only 6 subgroup in S4. You don't need to do that actually. You just need to find 6 is enough. Okay? I mean, well, you can show that there's only 6 of them, but there's extra word. Because you just need to find 6 subgroup. It doesn't say that. It doesn't say that. Determine all the 6 subgroups. Or it just says that there's only 6 subgroups. Then 你就要证明它只有6个嘛。把这里是叫你找6个 ，find 6 of them. Okay, no need to show there's only 6. Okay. If you want to prove there's only 6 subgroup in S3, it's also not hard. Also not too hard. Yeah, you can do it brute force. This question, some of you do it brute force. 什么意思呢？ To determine the inverse image, right? What do you do? What one way you can do? You just map everything across, see why they map to, and then look at the pre-image. Okay, you can do that. Or some of you just found one of the pre-image and then try and build the subgroup out of that pre-image. Then you need to justify why is it enough to generate your subgroup. So different way of writing will need different way of justification. So if you found out that I give you less mark or you already argue such that I didn't see it, then you can see me. You can talk to me. And maybe I can give you more marks. Okay? If you think that I missed your argument, you can talk to me. Okay, then the last one here. Let G be a group that has a normal subgroup of order 3 and 5 and then prove that it contains an element of order 15. So I give a hint in your group chat saying that an isomorphism will preserve the order of element. Okay, so how do you use that hint? So basically we build an isomorphism between the product group of J cross K into G, not to G. A lot of you think that G is just JK. It's not true. Okay, this G might be larger. What you can only show is this J cross K here is isomorphic to some product set here. And then you need to show that this is a subgroup of G. Okay, that's all. But this is enough already. Is this enough? If you can find an order 2 elements here, you map inside a subgroup inside G, then it is a element of order 15 in G. Yeah, it's enough already. No need to reach the whole G. Okay, a subgroup of G is enough. And then how to show this isomorphism? You should be familiar with this product and a product set. How are they isomorphic? There's a theorem. Okay, there's few property to check. What do you need to check out? If there's an isomorphism here, you need to check that J intercept K is just identity, and then you need to check what J and K are normal subgroup in JK. Okay, and then the other property is G equals to JK, right? But in this case here, the G you want is JK. Okay. Another thing is this G is fixed already. Some of you still copy the G inside the theorem. Okay, so there's a notation clash. Okay, notation clash here. Okay, so here G already get fixed. Okay, G is something that contain normal subgroup of order 3 and 5. And then this JK is what correspond to this normal subgroup. Okay. Yeah, so this okay. And yeah. So one thing I want you to justify is why if you have a prime order, then your intersection is containing only identity elements here. Okay, some of you just say that the GCD of the order is 1, then the intersection only contain identity. Why? We haven't proved that. But for this, I think we prove it. We somewhat prove it. It's the same technique we use to show that, to show what? To show that the order of an element is equal to the order of the cyclic subgroup region. Yeah, it's the same technique we use there. Yeah, and then yeah, that's next one. Any question? Have you checked your feedback? Please check your feedback. How to learn properly? 怎么学习啊？你要读我给你的 feedback, understand it. If you don't understand, you have to come and ask me what to fill in, okay? To be better next time. Right. So 我们快快讲一下这个成绩如何。子涵没有在啊？子涵没有在，但是 Raysha 没有在，是不是？我想要称赞一下 Raysha。Okay, so this time got a few got 29, 30. So they are Sao Qi, Jasmine. Yeah, Jasmine got improvement. And then yeah, and then Yuxuan also got improvement. Yuxuan 29是吧？ check 了吗？ Yeah. 一层 and then yeah. So another one is Rachel. Rachel 把我的 assignment 做到像 project 这样哦。把我的 assignment 做到像 project 这样，把那个图全部画出来，把那个之间的关系都画出来。All the relation between the subgroup， 把它画出来。Yeah。但是他很奇怪，这个人很奇怪了，他只做一题吧，每次，他只把一题做到极致，其他就正常。然后这个人很奇怪，他做100啊，下次问问他一下，他今天没有在。Yeah. 他把我的 assignment 做到像 project 这样子。OK， yeah, very good。这个是那个 subgroup 之间的关系。OK。All right. Any question before we break? Oh, finish. Yeah. adjourn to next week. We still have how many more lecture to go? 4 lecture. Okay. Yeah. 赶快啊，见你们次数越来越少了。Okay, so see you next week.